A circle is a plane curve where all points on the curve are equidistant from a fixed point called the center. And this constant distance is known as the radius. The diameter is twice the radius and cuts the circle into two semicircles. The circumference of a circle is its total length, or the distance around it. Think of this as the circle's perimeter. Dividing the circumference by the length of the diameter produces a number we call pi, which is approximately equal to 3.14159. This is true for all circles, regardless of their size. When rearranging this formula, it is clear that the circumference of a circle also equals to pi times its diameter. For example, if this circle had a diameter of 10 units, we could easily find its circumference by multiplying 10 by pi. For a circle of radius r, the area of a circle, that is, its interior, equals pi times the square of the radius. For example, the area of a circle having a radius of 13.1 millimeters, which is the radius of a quarter, is approximately 539.1 square millimeters. Let's focus on a few more definitions by first extending two radii that will meet at two different points along the curve. The vertex that is formed at the center of the circle is called the central angle. The curved distance between the 2 points on the circle is called the arc, and the area enclosed by the two radii and the arc is termed a sector. On the contrary, an inscribed angle is one whose vertex is on the circle. If an inscribed angle, call it phi, and a central angle, call it theta, subtend the same arc, the central angle is twice the inscribed angle. Let's now add some straight lines touching our circle. A tangent to a circle is a line that touches the circle in just one point. Here, the tangent t touches the circle at point P. A secant to a circle is a line that intersects the circle at 2 points. The secant line S cuts the circle at 2 points A and B. A chord is that portion of a secant joining 2 points on the circle. Line segment AB is a chord. A segment of a circle is that portion cut off by a chord. Now let's discuss two theorems concerning chords and tangents. The first theorem states that the perpendicular bisector of a chord, which is a line that intersects the chord at 90 degrees midway through, will always pass through the center of the circle. Moving on our second theorem, it states that a tangent to a circle is always perpendicular to the radius drawn through the point of contact. If we were to draw a second tangent from the same point outside the circle, it will make equal angles with a line drawn from the circle center to the external point. The distance from the external point to each point of tangency are equal. Here, PA equals PB. Also, angle APC equals angle BPC, and ACP equals BCP. Turning now from tangents to chords, if two chords in a circle intersect, the product of the parts of one chord equals the product of the parts of the other chord. Here, A times B equals C times D. For example, in the following setup, the value of x can be found by multiplying 16.3 by x and making that equal to 12.5 times 10.1. Rearranging for x, we find that x is 7.75. Finally, when dealing with semicircles, any angle inscribed in a semicircle is a right angle. Extending a line from this point to here and another from the same point to here generates a 90-degree angle.